Rational number. What is a rational number? The way its name is, a number which is rational means a number which is kind of definite, a number which has boundary, kind of integer or a whole number, like 1, 2, 3, 4, 5. It's a definite. It has boundary. It's not limitless. Okay, so that is a rational. It is a rational. So a number, whole number, 1, 2, 3, 4, 5, 6, is a rational. It should not be undefined. It should not be limitless. If that is the scenario, it's a rational. A fraction number is also a rational. If it is a kind of definitive, it is limitless, it can be defined. 3.5, 7 by 2. 7 is kind of whole number, 2 is whole number. So, if a number can be represented as numerator, denominator, where numerator is a whole number, denominator is a whole number, number is a rational number. 3.5 equal to 7 by 2. 7 a whole number, 2 a whole number or integers. 3.5 is a rational. If I go with numerator and denominator, then if I say 7, 7 equal to 7 by 1, 7, 1, whole number. So 7 is a rational. So if a number is represented as numerator by denominator, where both are integers, then number is a rational. If I go with this fundamental, can I say the square root of 2 to the power 1 by 2, the square root of 2 is a rational? So, I can say, I think square root of 2 is 1.44, something like that. So, keep on going. So, can I prove that the square root of 2 is a rational? Okay, so I can prove. So, a square root is a rational number. So, it can be represented by two integers, p by q. So, a square root 2 equal to p by q. P is numerator, it's an integer. Q is numerator, denominator, and it's an integer. So now, if I say a square root of 2 equal to p by q, I have to find p and q. And if I prove both are whole number, both are integers, then a square root of 2 is a rational. Okay, so I will proceed. Square root of 2 equal to p by q means 2 equal to p square by q square. P square equal to 2q square. P square minus q square equal to q square. Simple. P square minus q square equal to q square. If that is the case, then p plus q multiplied by p minus q, that is p square minus q square. So p plus q multiplied by p minus q equal to q into q. Okay, so if I go with this concept, then p plus q equal to q, p minus q equal to q. If p plus q equal to q, means P is 0. And if P minus Q equal to Q means P equal to 2Q. Okay, so I think I can go beyond this. So now we'll come to point where P plus Q into P minus Q equal to Q into Q. If Q is kind of integer, so I can say Q into Q or Q square is X into Q into 1 by X into Q. Now it makes more sense. I cannot say Q into Q. Q square is Q into Q. Q square is X into Q into 1 by X into Q. So P plus Q into P minus Q equal to XQ into 1 by XQ. Okay. So if Q is kind of a whole number, then multiplied by X or 1 by X. Okay. So it should be whole number. I mean, X should be whole number. Okay. So P plus Q multiplied by P minus Q equal to X into Q multiplied by 1 minus 1 by X into the Q. If that is the case, then P plus Q equal to X into Q. P minus Q equal to 1 by X into Q. Now we have to kind of find first X, then we'll proceed. So P plus Q equal to X into Q. So P equal to X minus 1 into Q. P plus Q equal to X into Q. P equal to X minus 1 into Q. Other side, P minus Q equal to 1 by XQ. So P equal to 1 by X plus 1 Q. So 1 is P equal to Q X minus 1. 1 is P equal to Q 1 plus 1 by X. Since both sides P is there, so I can say X minus 1 equal to 1 by X plus 1. If that is the case, then X into X minus 2 equal to 1. X into X minus 2 equal to 1. X minus 1 equal to 1 by X plus 1. X into X minus 2 equal to 1. Okay. Now I have to find integer X where this should happen, that X into X minus 2 equal to 1. It's not possible. If X is 0, then anyway 0, it cannot be 1. If X is 1, then it is minus 1. This is not 1. If X is 2, then it is again 0. X is 3, then it is 3. X is 4, then it is going beyond. Up. It will not come to 1. So now X is minus 1, then it is minus 1 into minus 3, that is 3. If X is minus 2, then minus 4 into minus 2, minus plus 8. Again it is going beyond 1. So for any integer, X into X minus 2 cannot be 1. So square root of 2 is not rational. It cannot be kind of represented as P by Q, where P and Q are integers. Because it comes to a situation where it is not possible. Same way, we can say as square root of 3 is also not a rational. If you go with the square root of 3, then I believe we'll come to similar situation. Okay, so it is also not possible. What about square root of 4? If I go with the square root of 4, then I'll come to a situation where p plus q into p minus q equal to 3q square. Earlier it was 1q square. Now it is 3q square. That is equivalent to x cube into 3 by x cube. Sorry, x into q into 3 by x into q. P plus q equal to x into q. P minus q equal to 3 by x into q. Okay, so if p plus q equal to x cube, means p equal to same x cube x minus 1, and p minus q equal to 3 by x into q, p equal to 3 by x plus 1 into q. So we come to same situation. X minus 1 equal to 3 by x plus 1. X into x minus 2 equal to 3. Okay, so we can go beyond this. Like I can say p plus q into p minus q equal to 3q square. That is, now earlier it is x into 3 by x. Now it is 3 by x into x. So p plus q equal to 3 by x cube. P minus q equal to x into q. So p plus q equal to 3 by x cube. So p equal to 3 by x minus 1 cube. And on this side, p equal to x plus 1. So x plus 1 equal to 3 by x minus 1. So x into x plus 2 equal to 3. Earlier we had x into x minus 2 equal to 3. Now we have x into x plus 2 equal to 3. It's possible if x equal to 1. If x equal to 1, then p plus q is 3 by x. So that is 3q. So we can do same situation. So square root of 4 is 2, and square root of 4 is rational. The square root of 2, if we go with this fundamental 1 by x and x, again it would not be possible. So square root of 2 is not a rational.